Here we're going to look to apply elimination. So florists are making regular bouquets and mini bouquets. Each regular bouquet has 5 roses and 11 peonies, and each mini bouquet has 3 roses and 5 peonies. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? Now, because I've looked over this problem already and have an idea of where to go, what I want to point out is that it's a little bit tricky setting this up, but once you have it set up, it's not too bad. So what I'm going to do is I'm going to highlight the information here about each type of flower. Most likely, when we're first trying to set these problems up, someone might see 5 roses and 11 peonies, and they would say, all right, 5x plus 11p, and that, or 11y, and that would have to equal a total amount. We don't actually know what that total amount is when we're combining both the roses and the peonies. But what we do know is that for the roses, total amounts, we're going to have 5 per regular bouquet and 3 per mini bouquet, and that's going to total up to 118. So we're looking at is defining our variables is going to be the thing that we have to be careful of. So we're going to say let x equal regular bouquets and let y equal mini bouquets. So now my second equation is 11, sorry about that, 11x plus 5y equals 226. All right, and this is for roses, and this is for peonies. So now we have an equation that, 2 equations that we can work with. We have our system of equations, and we can solve this. Now, clearly our x values don't match up, our y values don't match up, so we cannot add or subtract these to eliminate. So we are going to need to do some multiplication here. You can eliminate x's or y's. The y values are slightly smaller, so that's what I'm going to use in this case. I'm going to rewrite my equations first. I'm really just rewriting them to give myself some extra space and to color code some things. I'm going to eliminate y's, so I'm going to take this 5 here and multiply my first equation. So I get 25x. So 25x plus 3y equals 5 times 118 is 590. And then I'll do the same thing with the y values, but this time I'm going to multiply by 3. All right, remember we need equivalent expressions or equivalent equations. So we have 33x plus, I made a mistake here, rushing through this problem. So up here this should be 25x plus 15y. I think I said it but didn't write it down. And then 15y. 226 times 3 would be equal to 678. So now we have x values, sorry, not x values, y values that match up. So they're the same sign, so we're actually going to subtract these equations. So we get 25x minus 33 is going to give us negative 8x. The y values are eliminated, and 590 minus 678 would be negative 88. So we can solve for x by dividing by negative 8, and x will be equal to 11. So that tells us that we can make 11 regular bouquets. So we'll get to that in a second. But let's go back to one of our equations. I'm going to choose the first one. I'm going to go with 5x plus 3y equals 118. I'm going to substitute my x value in, and I will solve for y. So y would be equal to 21. So how many type of bouquets can we make? Well, X are the regular bouquets, so we can make 11 regular. And we can make 21 mini. For this problem, you worked with equivalent equations, equivalent systems of equations. Really, the hardest part about this problem is setting up the equations. This one can be a little bit challenging because normally we see groups like 5 roses and 11 peonies, and we think, all right, 5x plus 11y. That's not the case. We're not going to define our variables as roses and peonies. The variables x and y will be equal to the regular and mini bouquets. So hopefully you're okay with the actually solving the system. Again, you might have had some trouble setting that system up, but solving the system using equivalent equations should be getting the hang of by now. That's it for this one.